We are here with another episode as part of our EigenLayer series. Today we welcome Ellie from Espresso to talk about Espresso's sequencing, marketplace, and fast finality.
Welcome to EigenLayer Unlocked, an interactive educational journey through the EigenLayer ecosystem created by technical founders and builders for the entire crypto community. A special thank you to our partners, AltLayer, Polymer, Authentic, Skate, and Lagrange for helping to make this happen. Our goal is to raise the collective knowledge of the EigenLayer AVS ecosystem and unpack the technical designs of the top teams in space. Welcome to EigenLayer Unlocked.
Welcome to the Rollup. We are here with another episode as part of our EigenLayer series. Today we welcome Ellie from Espresso to talk about Espresso's sequencing, marketplace, and fast finality. Welcome, Ellie.
Yeah, thanks for having me. All right, I'll dive right into it. So I'm Ellie. I am a researcher and engineer at Espresso. And yeah, today I'm going to describe our sequencing marketplace and fast finality layer, why we even need those in the first place, and then how they use EigenLayer to make them even better. So first off, why do we need this sequencing marketplace and fast finality layer? That's the obvious question. Well, the reason is composability. This is a really hot word all the time on crypto Twitter, but this is what we want. And what do we mean by composability? We mean that applications on different chains can coordinate as if they were on one chain. So if you look at today, we don't really have this. So let's take a couple of examples. So a lot of the rollups that exist, they each have their own dexes deployed to each rollup. Each of these dexes has its own liquidity, and it's not very seamless to transfer this liquidity between all of these different chains. And it's not very efficient to have this liquidity in all of these different places. And then secondly, I think that another example is app chains. So I think app chains will be really awesome in the future, and I can see them growing. But app chains, because they're focused on one specific application, they may never get a whole lot of liquidity or a whole lot of, it's very difficult for an app chain to maintain the composability it has on the L1 on their own L2. But there's a lot of benefits to creating an app chain. Like they get customized sequencing, they can capture a lot more fees. So how do we solve this? Well, if we can make all of these rollups composable together, then we can solve this, and app chains can become a lot more powerful. And then, of course, we have a lot of words that get thrown around: cross-chain interoperability, atomicity, synchronous composability. They're all related. They all mean sort of different things, but really the goal of each one of these is composability. So now the obvious question is, okay, well, how do we get to composability? The answer is that it's actually a lot trickier than it seems. And this is why we see a lot of projects working on it, including Espresso. It's very tricky to do it in a way that is seamless, but also is incentive compatible to all of the participants. But I'll explain how Espresso is going about this. So back to the question, how do we get composability? Well, we're building a sequencing marketplace and a fast finality layer. That's how Espresso believes we can get composability. And then where EigenLayer comes in is EigenLayer serves as this foundational infrastructure in which both of these things can be built on, and we can get a lot of really cool benefits from that, which I'll go into later. All right, so I'll go into the marketplace, and then later I'll go into the finality layer. So the marketplace is fundamentally, it's just about coordination. That's all it is. So if you recall our definition of composability, we're just trying to coordinate as if we're on one chain. And this means that we need a way for different chains to coordinate their sequencing. If you want to have composability between two different chains, they need to be, where it's best that they're sequenced together. And if we make an analogy to the L1 in Ethereum, this is true. Apps that are deployed on Ethereum are sequenced together. They're sequenced in the same Ethereum block by the same party. And so really, to get composability among all of these different chains, we need to have something very similar to that. But there's the issue that we have sovereignty. So this is a really popular reason for app chains, is that applications don't want to give up their fees to L1 proposers or L1 builders. App chains also want to be able to customize a lot of things. Like they want to customize their sequencing rules. They want to customize their VMs, all of these different things, which makes an app chain great. So we want to enable this coordination without forcing rollups to give up their sovereignty. And so this is where the marketplace comes in. So I'm going to go through how the marketplace works at a high level. So we have these rollups, A, B, C, and D on the left side. And they are going to sell their sequencing rights to the Espresso marketplace. The Espresso marketplace runs an auction. That's essentially just what it is. And so each rollup will decide to sell their sequencing rights. And then on the right here, we have several different sequencers. And these are parties, well, they're in charge of sequencing transactions, but oftentimes we can think of them as builders. They're very similar. And oftentimes they, in fact, are the same party. So these sequencers or builders will bid in the auction to get sequencing rights for all of these different rollups. And the key part here is that the sequencers can bid for multiple rollups at the same time. And so, for example, in this case, one sequencer, they bid for rollups A and B because they think that they can get a lot of benefit from sequencing those together. Maybe there's a lot of interop or cross-chain messaging between those two. And then the other sequencer, they bid for C and D. So this is just one example, but in this case, the auction or the Espresso marketplace, it will find the most optimal solution to designate these sequencing rights. So the auction will run a combinatorial auction. It'll consider all of the different possible combinations that people have bid on, and it'll choose the one that maximizes the revenue across all of the rollups. And so this is really great. And then how this works is, step one, rollups sell their sequencing rights to the auction. Sequencers bid in the auction to earn the sequencing rights, and then the auction computes this maximum revenue across rollups. This is, what the marketplace is fundamentally. So do we have composability like we want? Well, yes, I'd argue yes, because the sequencers, since they can earn sequencing rights for multiple rollups at once, they can sequence those rollups together, and they can ensure that we have this really seamless composability between the rollups that they sequence together. So yes, this is great. But do we have sovereignty? Well, maybe not yet. So a clear issue with what I initially described is that, the sequencers are kind of collecting all of the sequencing fees, right? They're deciding the order. They're going to generate MEV potentially. They are going to earn transaction fees. This isn't good for the rollups at all. And rollups don't want to, lose their sequencing fees. So we're going to add an extra layer. And this extra layer says that the proceeds from the auction that the Espresso marketplace runs actually get redistributed back to the rollups based on the proportion of how much they contributed in the marketplace. So, for example, let's say one rollup, let's say the total value of all of the bids in the marketplace was $40. And each rollup contributed equally, well, then each rollup would be refunded $10. So in this way, rollups really do not have to lose their revenue. And you can actually design it such that rollups are always better off by participating in the marketplace rather than not. And so, well, okay, do we have sovereignty yet? Well, still no. And I'm going to introduce another thing, which is a reserve price or a floor price. So we can end up in the scenario where a rollup is selling their sequencing rights, but maybe the people bidding on it aren't willing to pay what the rollup thinks is a fair price. And the rollup says, hey, I can make that much money just sequencing for myself, so I'll just sequence for myself. So this is where these floor prices come in. And these floor prices can be designated by each rollup, and they can be changed over time. And in order to earn sequencing rights, the builders must bid at or above this floor price. And if there's no bid that clears this floor price, then the rollup gets to sequence for themselves. And then they, again, get to keep all of their sequencing fees like they normally would. So this is really neat because rollups can be always better off in this marketplace, and they can also access this coordination to enable shared sequencing. Okay, so let's talk about how EigenLayer fits into all this, though. EigenLayer has a bigger part in the finality layer, which I'll get to, but the really neat thing about EigenLayer restaking is that it really simplifies based sequencing. So Espresso can absolutely enable based sequencing. And based sequencing is when you enable the Ethereum L1 proposer to also build blocks for rollups at the same time that it's proposing a block on Ethereum. And the way that EigenLayer helps this is that every node that is staked in Espresso's protocol is actively participating in Ethereum's protocol. They are actively staked in Ethereum's protocol, so you can assume things. You can generally assume that they will be up to date on the latest state of Ethereum, etc. And then also because you know that the Espresso software can coordinate with the L1, Ethereum client, you can then actually sync up the two. So maybe an example would be, okay, I'm the L1 proposer and I want to build rollup blocks in Espresso. Well, that's only valuable if I'm building the blocks during my Ethereum proposal slot time. And the tricky part is you need to sync those up to make sure that that's what happens. Because otherwise it could be very common that the case is the L1 proposer gets sequencing rights on Espresso, but it's like after their proposal time, and then they can't do anything meaningful with that. So EigenLayer, because you can work under these assumptions that that nodes are actively participating and proposing in the L1 protocol, this makes base sequencing a lot easier, which is really cool. Oh yeah, I had a couple of images. So base sequencing, Ethereum proposers. And I would argue that this kind of gives us composability plus plus. So our initial definition of composability was that all of these different chains could interoperate together and they could act as one chain, but we didn't really mention the L1. And so this composability plus plus means that we get composability between rollups, but also between the L1 and rollups, which is a very, very powerful property to have. All right, now I'm going to go on to the fast shared finality portion of Espresso. So we have our same picture of the auction. The rollups sell their sequencing rights and sequencers bid on them, but we're going to add a few more steps. So this is the marketplace, and then to the right, we're adding the finality layer. So what happens with the finality layer is that the blocks that the sequencers produce get sent to the Espresso network, and the Espresso network finalizes them. And this finality, ultimately, it's not Ethereum finality. The rollups do still have to settle for Ethereum. But the idea is that the finality you get from the Espresso network is extremely strong, that you can have a very good guarantee that it will actually be final on Ethereum. And the way that this finality works, it's a consensus protocol that we've designed. It's called Hotshot. It's in my opinion, it's really interesting. It's based on hot stuff. It's a BFT protocol, so it has the same. It's very similar to how Ethereum does finalization, where you have a block proposal, and then everybody has to vote on it, and then it gets justified, and then everybody votes on it again, and then it gets committed. This is a very similar scheme. But the really important parts are that this scheme can go so much faster than Ethereum's finality. So you can generally expect to get finality between, hopefully with less than 4 seconds on average, which is really good. So this is great. And this finality layer is really strong. But let's see, why do we need this finality layer anyway? It's fast, which is great, but do you actually really need that? So this finality layer gives us a few good things. One thing is that it makes it easy to enforce composability properties among rollups. So a user likely wants an atomic cross-chain transaction. An atomic means that they want both sides of their transaction to succeed on each chain, or they want them both to fail. They really don't want one to succeed and one to fail. So we want to enforce this atomicity. And to do this, rollups need to be somewhat aware of other rollups. Generally, rollups are not aware of other rollups. They have no idea how another rollup might execute its VM. They really don't know. And so we can have, other services that come in and can do this, can be knowledgeable of like both rollups at once. And where Espresso comes in is that you don't have to wait for the rollups to settle to Ethereum before you can figure out what the shared state is. This is important as well because rollups do not all settle to Ethereum at the same rate. Some rollups settle every few minutes, which is great, but then you may have a ZK rollup that's only settling once every 30 minutes to reduce their gas costs. So this is really not ideal if you're trying to figure out if your transactions executed or did not execute. So since both of the rollups that your transactions are on are finalized through Espresso at the same time as each other, you can then immediately see, okay, my cross-chain message worked or it didn't work. And this is really good. This reduces a lot of the latency in these cross-chain experience. And then the other thing is you get faster composable finality than the L1. This is actually very similar to what I just said. Normally you would have to wait on Ethereum to see if your transactions made it or not. And in the worst case, the rollups might have to wait until they're settled on Ethereum to even check like what the other rollup is even doing. And now maybe there's L1 function calls involved and this gets really expensive. Maybe they need to verify a ZK proof of another rollup and this gets like expensive. So the fact that you can do this before settling it on Ethereum is really advantageous. All right, but then let's finally go to the EigenLayer part. So how does EigenLayer help all of this? So first, EigenLayer gives you very strong economic security. This is probably the reason most people are using EigenLayer for restaking. If we want this finality layer that's really strong and that can give these really strong pre-confirmations to rollups, we need to have a lot of economic security behind that. The easiest way to do that is to use Ethereum's economic security. The really wonderful thing about Ethereum that makes it very unique compared to other chains is that it has so many nodes participating. The nodes are relatively decentralized and it has so much economic security behind it. So through restaking, we can basically use that economic security and we can have a very secure network. We've actually designed our network to be able to handle all of the Ethereum validators if at one point it needs that. And so this is really, really great. This gives users a very strong guarantee that a pre-confirmation from Espresso will be finalized on Ethereum. The other thing it gives us is transparency. So when different projects use EigenLayer for restaking, it's very transparent where stake is allocated and which nodes, like which operators are running nodes in multiple protocols. And in my opinion, this is very helpful for risk management. In the case, for example, say that you have Espresso is running and you have another project that's running, and a lot of the operators overlap and they're run by the same operators. This other project has this major slashing event and a lot of money is lost. Well, that is going to affect Espresso. Like, even if it's not the exact same stake that is being used in Espresso, those operators probably now have to cover their clients' losses, so they're going to withdraw from Espresso, etc. And if you have transparency into this process and it's very public, the network can be sure to maintain accuracy of its economic security. So the worst thing that would happen is that you say, oh, Espresso has $10 billion worth of economic security, but then some slashing event happens over here, and actually Espresso doesn't have $10 billion, but it's operating as if it did. You really don't want that. So with EigenLayer, you can get transparency into what's happening with other protocols, and this reduces the risk of Espresso. And then the final thing is shared infrastructure. So Espresso will have slashing for attributable faults, very similar to Ethereum. We will slash if someone tries to double sign or equivocate something, etc. And the good thing about EigenLayer is that a lot of projects can use the same slashing infrastructure. Each project might write their own specific slashing rules, but the shared infrastructure is very important because slashing is something that is very persnickety. You really need to make sure that you get it right. You really don't want to slash people due to a bug in the software or anything like that. So having a shared infrastructure that everybody can use, can audit, etc., is really powerful in making sure that these slashes are safe. And yeah, so that's pretty much the overview of the Espresso marketplace and the Espresso finality layer. They work together in tandem. That's the end of my presentation. And so I guess in summary, just to conclude, the marketplace is mainly about coordination. It allows rollups to coordinate their sequencers together so that users can have transactions sequenced across many rollups at the same time. And this gives us a lot of great things. It helps app chains, it helps liquidity, all of these great things. And then also Espresso has this finality layer, which can serve as a very strong pre-confirmation before rollups settle on Ethereum. And yeah, with that, that's all I have.
Awesome. Yeah, you were on a roll, so I sort of saved my questions to the end. But I think overall that was phenomenal. You kind of addressed quite a few things that we'll dig into a little bit deeper. But starting with some of the EigenLayer things, you hit on slashing. I think one criticism of EigenLayer in general has been this idea that everyone has to design their own slashing conditions and slashing contracts. But in fact, that's not the case. You can read a lot of these modules. Maybe there is some sort of attributable fault smart contract where you have double signing and equivocation in there. And then that's somewhat generalizable to a set of the AVSs, and we can reuse some of those contracts to get some more shared infrastructure. So you hit on slashing rules, and those are pretty much the two key reasons that operators could be slashed. But the other side of that is the APY for stakers to stake into Espresso's AVS. And so because operators are taking on some risk in providing the capital, they could be slashed. There's kind of the reflective reward or APY that you're paying for the economic security. So kind of talk us through how operators are being incentivized and how stakers are being incentivized essentially from, and then that demand will go and pay the APY for stakers.
So the Espresso network is a data availability layer and a sequencing layer. So the way that validators in the Espresso network can earn fees is basically to sequence data in Espresso, you need to pay a small sequencing fee. This is very similar to a lot of other data availability protocols. And you're paying this fee to ensure that your data remains available for a very long period of time. And then, so yeah, you're paying that. And then also we have the auction, which is generating revenue as well. So the main way that validators would earn APY by restaking in Espresso is through these sequencing fees that are paid to the network to hold their data and sequence it and keep it around forever.
Awesome. Okay, that makes a lot of sense. Okay, great. So stakers are incentivized to stake into these validators that are kind of like running the nodes for Espresso. These operators and stakers are earning these APYs because the sequencers are paying a fee in order to sequence the transactions, right? And so they're paying a fee to the Espresso protocol, and then they're also buying the rights from the rollups to sequence their transactions. And so I'm going to skip back here to some of the sequencing slides and talk a little bit about incentive compatibility, because I think that is a key thing here when it comes to, I think maybe it's the next slide. So, okay, so we have kind of just to illuminate like all of the economic actors and incentives at stake here. We have rollups, they have order flow, they have transactions, and they could sequence the transactions themselves, but they wouldn't have composability between them. And so maybe we're missing out on atomicity and some order flow that would be extra excited about composability is kind of getting snubbed. And then we have sequencers that in the Espresso marketplace could provide cross-chain synchronicity through sequencing transactions. And then we have Espresso, the protocol, which kind of takes it has to validate consensus. And so it takes this protocol fee, and that's ultimately how validators earn APYs for coordinating this protocol. And so these sequencers are going to bid at least the reserve price to these rollups. If it doesn't meet the reserve price, the rollups will just kind of sequence on their own. But let's say it does meet the reserve price, and they're sequencing for at least 2 or more of these rollups. Then we have to choose the combination that maximizes revenue across the rollups. And I think this has been like the most contentious part, because how do you choose the combination that provides the maximal revenue to rollups? What if one combination provides 20 revenue points to rollup A, but there's another one that provides 20 to rollup B, right? How do you and let's say rollup C gets 5 in the first case and 10 in the second place. So either way, they're not as much, but how do you choose if is there a tiebreaker mechanism, or ultimately do you have to choose preference over one rollup or the other? How are some of these decisions made?
Yeah, so this is a really good question. So the marketplace computes the maximum revenue across all of the rollups. So it doesn't ensure that every single rollup is maybe getting the maximum bid that someone bid for it. It is possible that, let's say, someone bid for rollup D and they were willing to pay $10, but someone bids for rollup A, B, and C, and they're willing to pay $50. That may not result necessarily in rollup D getting more than $10. Or it could actually. In a lot of cases it will, but it's not guaranteed. So this is how that works. And when the auction is deciding these different combinations of rollups, so it takes a lot of things into consideration. So I actually didn't touch on this, but this is a very interesting extension we can add to our marketplace. Is instead of just selling sequencing rights, you can think of the rollups as providing intents. I'm hesitant to throw another buzzword in here, but rollups can kind of state their intents. They could say, okay, I need to match this reserve price. And they can also state the intent of I really want to also be synchronized and sequenced with Arbitrum, let's say, because that's really important for my rollup. So they can specify these intents, and with that, the auction will kind of come up with the best case scenario that gives the entire protocol the most revenue. And the way that the revenue is split between protocols is based on reserve prices. So each rollup has a reserve price, and this price is what they think their sequencing is worth by itself. And so when you're redistributing the revenue to all of the rollups, you take up all of these reserve prices and you add them up, and then you calculate the percentage of each one. And then you take the revenue that's earned from the auction and you divide up that percentage based on, how much each rollup was worth. And so that's how you kind of decide how much each rollup is contributing into the auction. Because you could have the case, let's say, that you have a rollup that's really popular and sequencers will bid a really, really high price to sequence for them. And then you have another rollup that's maybe not so popular, and builders are not going to, bid as high just to sequence for them alone, but they'll bid a really high value if they can sequence for them and this really major rollup. And in this case, it makes sense that most of the revenue should go towards the really popular rollup that's really driving the high price of that bid. So this is how we allocate the revenue to each rollup, kind of based on how much value they're adding into the network.
Awesome. Okay, yeah, that clarifies things quite a bit. So it's not about the revenue each rollup gets; it's the total aggregate revenue that A, B, C, and D could create together. Sequencer is going to bid on that total value, and then we're gonna choose the bid that has the maximal total aggregate value.
Yes.
Okay, and then you put out intents. I think that's great, because there is a declarative nature to this. You can say, you can define your outcomes, and then you have a competition to try to fulfill those outcomes the best way possible. like you said, we have the reserve price, and rollups can opt in or opt out. I imagine at each block, right? Like each
Yeah.
rollup block, they can opt in and out.
Yeah,
And
each
so,
rollup block. Yeah.
I imagine like a lot of times these rollups are going to set really high reserve prices because a lot of times they can make quite a bit of revenue on their own.
Mhm.
Recently we did a podcast and kind of dove into some of the numbers with Justin Drake, and in fact, Base is making like 800. They're making like
Yeah.
$200 million a month, I think, and 80% of that is from MEV, and so and SexDex arbitrage and lever, and so
Mhm.
that is going to lead to quite a high reserve price.
Yeah.
And so oftentimes, they might set a super high reserve price. Bidders may or they may not meet that, or let's say Base is rollup B in this case, and rollup B doesn't get let's say rollup B could stand to make $1 million on its own, and the total aggregate is maybe 5 million, but rollup B is only going to get 10%, not 20%.
Yeah.
And so they would opt out, right, for that block.
Mhm.
But they can opt in and out on each block. And so I imagine that a lot of times rollups are going to set quite a high reserve price. They may not participate in the auction every single block,
Mhm.
but even for the off chance that they do get some sort of composability benefit, it makes sense to at least kind of have a visibility into what it could be if they were to participate and take that on a per block basis.
Yeah.
And so I think the declarative nature makes a lot of sense.
Mhm. And yeah,
Um,
I guess it's a
and
quick
I was going to
response.
throw out another
Go.
buzzword actually. Oh yeah, please.
Um, yeah, so just a quick response is that when the auction is calculating the this combination that maximizes revenue, it will calculate to make sure that each rollup at least gets its reserve price back. So even if a rollup is only contributing 10% to the total value, so long as that 10% is greater than the reserve price, they will still be sequenced. But yes, like you were saying, rollups can opt in and out of this marketplace very regularly and on a block per block basis. And I imagine that some rollups will do that. I think it depends on, for example, app chains. Not all app chains may need composability all of the time. And it may make sense for them to opt into this, say, once every 10 blocks, depending on what that application is. Maybe it's like a gaming chain that doesn't really, need a lot of composability with other chains. So that makes a lot of sense. And then you may have DEX app chains who would probably opt into this all of the time because they get access to this shared liquidity from other rollups. So yes, what you describe is something I think will happen.
I mean, this is a long time that shared sequencer marketplaces, like composability has been discussed.
Yeah.
And to me, this in theory, this has always been possible. Like, I only want to participate if it's going to make me more money. Otherwise, I'll do it on my own.
Yeah.
It's a pretty simple principle. And so now we have the mechanism to complete that. Like, what are the downsides or the criticisms that you guys are hearing? Because to me, like, if I'm a roll-up operator, it's a no-brainer. I can either make the same amount of money or I can make more. Like, why wouldn't I do this? What are some of the criticisms that you guys are hearing?
Yeah. So this is a problem that we've been working on internally at Espresso a lot. And kind of the obvious question when I describe this is like, well, what if you have a cross-chain transaction between rollups B and C? Those are not sequenced together. And now maybe, you have to go back to using the old bridging approaches, et cetera. Like that's actually not good because you're not guaranteed that that a single user's combination of rollups will be sequenced in the marketplace together. So yeah, we've been actually focusing a lot on this problem internally at Espresso, and I think in a few weeks we should actually have something that we'll publish. We'll publish publicly, but the synopsis of it is that the role of coordinating between rollups can actually be separate from the sequencing of rollups, and it's very, very nuanced, but rollups can potentially sequence for themselves, or they can sell their sequencing rights to whatever sequencer. But then you can have this kind of coordinator come in, and the coordinator just makes sure that each rollup is aware of each other. But it doesn't sequence transactions. It's not taking transaction fees, etc. And because the coordinator can come in and do this, they can do this between rollups that maybe don't always get sequenced together. And so the benefits of this are that users can get cross-chain interoperability no matter which rollups they're going from. But the marketplace still provides an advantage, because if you have a shared sequencer, the shared sequencer can guarantee you things like execution. The shared sequencer can guarantee what price you're going to execute at, give you pre-confirmations, etc. The coordinator cannot do this. The coordinator may coordinate between two rollups and find out that all of the cross-chain transactions fail, for example. That could happen. But if they were being sequenced by the same actual sequencer, you wouldn't have all of those failed transactions. But yeah, so this is an issue that we've been thinking about, and how we plan to solve it.
Awesome. Okay. And so basically you have like, you have some cross-chain transactions between, let's say A and B, right?
Mm-hmm.
And then, let's say they were both to opt out of the auction, and you would have to
Mm-hmm.
revert back to the previous, like, whether it's mint and lock or intense based, you would have to kind of revert back to the original way. You couldn't do the sequencer composability, maybe because it's only C and D that are participating in the auction. And so A and B still have to figure out a way to know what's going on with one another. And so there's a coordinator, and so sequencers are kind of on the right part of this.
Mm-hmm.
And I see why you chose B and C actually in the first example, because it kind of works with this diagram. So what you're saying is that, and we have all the sequencers on the right, but there's actually like this middle layer of the coordinator that can read the state on both rollups at the same time and sort of work as like a central hub of data availability to check what is in the mempool of each rollup at any given time.
So sort of. So the coordinator would sit basically to the right of the sequencers. And so the coordinator would take in blocks that are already sequenced. And the coordinator would just say, okay, rollups, these are the messages that are getting passed between you guys. Now go and execute those like you want. The coordinator's role and like responsibility is very minimal. It's just to say, here's messages from another rollup.
Got it. Okay. That makes sense. Because it's actually coming from the fast finality layer, like the pre-confirmation is how they get, okay. One question I have is like, let's say, and you mentioned like an app chain, right? May or may not need composability, but then, another chain maybe really wants composability with Arbitrum.
Mm-hmm.
And, what if this is maybe, I'm just going to ask, but like basically, what if like there's a subset of transactions for a particular rollup block that really need composability because, it would really benefit them, but not all of the transactions in that block need composability. It's just a subset.
Yeah.
Would you be able to kind of separate these bundles apart and then synchronize some of them, but then opt out of the auction with the other set?
Yeah, that's a good question. And this is something that I've thought about. And at this point, I don't think that that's a way to do it. And the reason is because app chains or any sort of rollup might want to enforce certain sequencing rules. So even if you have a cross-chain message, they might want that cross-chain message to go at the top of the block, or they might want it to go at the bottom of the block. And so if you separate the two of them, it maybe works, but then you kind of need to recombine them in a way. And when you recombine them, you might end up with a different execution. So if I'm a user and I get a pre-confirmation for my cross-chain swap and it says it executes, well, then when these non-cross-chain messages are added back in, maybe it actually fails. But to address the issue is that, so sometimes blocks may not have a lot of demand for cross-chain composability. If depending on the rollups reserve price, they maybe still get shared or sequenced together. if you have no messages between chains, you can still have the same person sequence them, and maybe you can even still get a few benefits from that. This shared sequencer can give pre-confirmations, etc. But in the case that you don't have enough demand, then you can use this coordinator role that is very minimal, doesn't do any sequencing, and will just, coordinate the messages between the blocks.
Got it. Okay. And so from the conversations you're having, kind of the main opposition to rollups opting into this is when it doesn't make sense and you opt out and you have kind of like a set of transactions that revert because they don't really fit within this framework. But we're kind of adding the coordinator role to address that. I think all of us have a really common goal of like achieving synchronicity. This is something that I continue to hear over and over again. It's like, this is what we want. Even from the DeFi OGs, like this has been a very main value proposition of commerce on chain, like far and beyond, it's always been sort of this, like the composability of cryptocurrencies with one another and contracts. But then, we got so fragmented. And now it's like, this is the main core value principle of on-chain versus something like a Binance. Binance can probably be faster and cheaper because they don't do things in a decentralized environment, but they don't have the composability that you can get on chain. And so to solve this, I think it is kind of like this greater good thing that a lot of us have as a common goal. A lot of users want to see it. A lot of rollups want to see it, and sequencers can make more money too. And so, getting to the point where it is a no-brainer and rollups are, basically just ready to opt in. I think this is a point where a lot of us it still feels kind of idealistic, but this is where I think a lot of us want to get to.
Yeah, 100%. And to comment on that, so Espresso it's not the entirety of the solution. So there's other projects that also are going to help this. For example, wallets. When you have a cross-chain message, the user can't actually be generating both of these messages together. The wallet needs to know how to generate messages that send messages to another chain, etc. So like we need wallets on board. You need other projects such as like EigenLayer that are doing this proof level. So Espresso is only one piece of the puzzle. But yeah, I also will say mainnet for Espresso is coming soon. So hopefully this can be a reality very soon.
Awesome. And will you have launch partners? Rollups ready to go live on day one?
Sorry, I'm not sure if you can hear my dog barking in the background.
I can, but it's all good.
So our initial launch will be just the infrastructure, and any rollup can decide to use it if they want. And then really shortly after the launch, we will have partner rollups that will launch, be launch partners and are officially using our chain. Mm-hmm.
Awesome, because I really see the network effects here. They're kind of in plain sight. Like once you get rollups A and B, if rollup C wants to be composable with A or B, then they're going to have to join. Mm-hmm. And so it seems like, it's going to be slowly and then all at once as rollups sort of launch and are incentivized to participate in this ecosystem for composability and for their users. I guess kind of as we wrap up here, because this idea again has been around for quite a while, and so it's cool to to see it come to fruition, hopefully here very soon. But you guys aren't the only ones in this arena that are trying, to build this solution. And so, right now we have a lot of sequencers that are building kind of interoperability amongst rollups in their own cluster. And then we have rollups that are, looking, and sequencers that are looking to coordinate amongst different clusters. Will we see, kind of like a layer on top, if you will? Like we have the rollups, then we're going to sequence the rollups in a sequencer marketplace. But then is there going to be are we going to need a marketplace to sequence the sequencer marketplaces?
This is a good question. I think in reality, no, because I think that a lot of the projects that are working on things related to shared sequencing, they're actually not direct competitors. They're actually different components of the ecosystem that can, plug in together. Um, so for example, Espresso offers DA, for example, but rollups can always choose to use their own DA layer as well, and that's perfectly fine. Um, you know, rollups may opt in to using kind of one of these clusters, but that doesn't actually that doesn't mean that they can't also use Espresso as well every once in a while to gain interoperability with things outside of that cluster. So
Mhm.
I don't really view them as like competing, and because of that, I don't think we'll end up with like yet another third layer. Um, I think actually we'll just have all of these modular components finally come together.
Oh, that is the dream. Yeah. I think so too. Like off again, it doesn't when it reaches this point, it's a no-brainer and there is no incentive not to participate. And so even if you're participating, but you end up opting out for 99% of blocks,
Mhm.
you're still participating. Like as long as you're
Mhm.
in the ecosystem and you're aware of when it does make sense to participate, I foresee that, especially early on when there maybe isn't as, the shelling point of rollups where it makes sense to compose all the time. That's where I think a lot of rollups where it's like there's no harm, there's no incentive not to participate. Like why
Yeah,
not
no,
try
exactly,
it?
there really isn't.
And
Yeah.
then you can see how it goes. You'll
Mhm.
make as much or more. And then, that I think will help to kind of get off the cold start. And then once it gets going, it really seems like it'll get going. And I'm personally super excited for all of these applications that um, are not possible right now, but are possible when we have the levels of scale and composability that we get from fast
Yeah.
finality and composability amongst these rollups.
Mhm. Yeah, I 100% agree, and I think I'm most looking forward to app chains specifically. I think that, like, composability is the key thing that app chains really need, and it's a kind of the key difficulty right now, why it's very difficult to make an app chain. But when we have composability, app chains can be very common, and I think that that's awesome because apps like, instead of having your app deployed on yet another rollup, which is essentially a chain, your app is your chain, and you have full customization over it. So that's what I'm particularly looking forward to.
Yeah. Awesome. Um, it's always a pleasure. Yeah, I mean, this was great.
Mhm.
Always learn a lot, and it's really cool to see how Espresso has evolved since our last series that we did in Modular
Yeah.
March. So,
Mhm.
thanks for coming on again.
Yeah, no, it was great. Thanks for having me.